Here we go again. Hi, hello everyone. Hello, Microbehunter all over here. And welcome to another Saturday live stream. Again, like every time I have to do a little bit of housekeeping here. I have to see if everything works. So quickly let me check if I can hear myself. Yes, I can hear myself. So I am online. Usually there's always a few seconds delay. So when I say something, you have to, you're able to hear it about 5 to 10 seconds later. So, and yes, cool. Yes, hi. Now officially everything seems to be working. I see that several of you have already started to join in the chat. So hello all around the world, of course. Welcome back. I say welcome back because last week I was not live. I just put a video live at the same time. I've seen that basically, I'm now seeing that a lot of people are starting to join in again. As always, a couple of minutes at the beginning. Hi from Lithuania. It says here, good morning from Digger's Rest in Australia. Well, I have to say good evening because I am in Austria in Europe and it's now in the evening. So, and that's one of the nice things that so many people all around the world are joining in. Hello from the UK, from Belgium, from Northern Germany, from the Netherlands, from Slovakia. Sound and video works well. Thank you very much. That's always important because a couple of months ago I started the live stream and nobody could hear me. From Connecticut to the US, Rhode Island, US. Okay, from Norway. And from Germany again. Okay, so here we go. So what I would like to do today is the following. I'd like to do a little bit of microscopy with crystals, polarized light. It's not a new topic, right? I've been doing this already a few times in the past, especially if you know this stream and my channel, then you know that I like putting crystals under the microscope. But today I would like to do it slightly differently than what I did before, because I would like to melt the crystals over an alcohol flame. Okay, I'm going to show you how this works. And this is actually a live image that you see right here of citric acid. It looks nice under polarized light. My microscope has polarized light. Maybe yours doesn't, but don't worry. It's very, very, very easy to convert pretty much any microscope to polarized light. So that's actually probably one of the first things that you want to try out because it's really so cheap and easy to do that. You just need two polarizing filters, which you can buy quite cheaply. Many of you probably already know how to do that. Just 1 hour ago, I actually made those crystals. Actually, I have to be very honest. A little bit of background info here is I was a little concerned that the crystallization process would take too long. This was a little bit my concern. And for this reason, I prepared several slides. But actually, within half an hour or so, I already had those crystals. So we're able to probably even see them, how they actually start to form. And I'm going to show you how to prepare them. And I prepared 1, 2, 3, 4, 5. I already prepared 6 slides because I just wanted to make sure that at least I'm able to show you something in case it doesn't work. But the good news is it's actually crystallizing much faster than I actually expected. Yeah. So basically, rules of the game are as follows. Please do feel free to ask questions. After 1 hour, I'm going to answer all of the off-topic questions together. If you have any on-topic questions which you might want to ask, please ask them and I'll try to answer them right away as far as I can. And off-topic questions I would like to answer later on. Okay? So every now and then I interrupt myself. Wow! From even someone joining in from Ethiopia, Africa. I think we've never had that before. Okay, from Africa, that's really great. From Germany, from Belgium, Philippines. Yep. Okay, cool. So I just want to show you now a little bit of how this actually works. Maybe some of you already know it, maybe some of you don't. So it doesn't matter. I'm just going to start it at 0, kind of. And in order to do that, I'm going to switch to the desk view again, and I'm going to show you some of the things that I have here. This here is citric acid. It's looks like sugar, or, yeah, a little bit. Where can you get it? You can buy it at the supermarket. It is used also for cooking. If you want to make jam, for example, and you need to make it a little bit more sour, you can add this. Yeah? You can also use citric acid for cleaning purposes, because it removes calcium carbonate, so-called water stains that you sometimes have, yeah, that's because calcium carbonate generally dissolves in acid, so it can be also used for cleaning. Yeah, and you just be careful. It's really sour, so you don't want to eat the stuff directly, obviously. And those citric acid crystals here, I would like to now crystallize on a microscope slide. Okay. And in order to do that, if you want to make crystals, what you can do in many cases, in most cases, you dissolve them in water, and then you allow the water to evaporate. And then as the water evaporates, then the crystals will start to form, and then you basically can put it under the microscope, right? But the second method of actually making crystals is by melting them on a slide directly using heat. And then you spread it, and then you wait a little bit, 10 minutes, 20 minutes, half an hour, and then the crystals will form, and you can actually see the formation of the crystals live under the microscope. However, it's quite slow, okay? So that's simply something that I also would like to clarify. So I'm going to show you how to do that. And we're going to put it on the side, and we're going to wait for the crystals to form. And in the meantime, we can actually look at some slides that I already made last 1 hour ago, because the crystals already formed. But those slides that I make live, they will also form crystals, hopefully. Okay. So I'm just every now and then checking again over here if there are any questions. Yeah, there is a way to switch this around. I'm switching away from top chat to live chat, just to make sure that I'm able to see all of the messages here. Okay, so a little bit of background info as well. In order to melt the citric acid, what you do is you basically put the citric acid with the slide over a hot flame, right? In the past, I've also used a hot plate, for example, for cooking plate, and then in this case it kind of helps to hold the slide using some tweezers or so over and putting it directly on the hot plate, and then you can try to remove it again there. It's not always very practical, so then I switched over to candle, to melting it over a candle. However, candles have a disadvantage, and that is that those candles, they form black soot under the slide. I can show you if you want to, and therefore I decided, and that's the first time today that I'm trying it out, I decided to buy myself a little alcohol, how do you call this? Alcohol burner. It's, normally in a lab you use gas burners, but that's a little bit too dangerous for me, because if the gas leaks, it's not so nice. But these alcohol burners are quite convenient and much smaller as well. And because I'm not using them so often anyway, it just fits my purposes here. Okay, so yeah, I'm just reading some of the off-topic comments. Please feel free to post. I'll talk about them later. For example, here's already a question of bacterial identification using an electron microscope. I can talk about that later on as well. So what I'm going to show you now is a little bit, I just bought this. Look, I'm just going to show you how it came. Again, this is not sponsored or anything. I bought this stuff with I always have to say this, I bought this stuff with my own, on my own. And I'm using, sometimes I get donations, and I'm using those donations also for buying microscopy equipment and also microscopy slides that I'm going to share with you. It came along with a funnel. There are a couple of wicks that came along as well, and in here I just put some alcohol. It looks like this. You can see it's black because I already used it, and you can open it here, and there is the wick will actually, by capillary action, the alcohol will go up here, and then you're able to light it. I have to be a little careful here, obviously, because right here in front, on top, it's shaking now. That's my camera. You see it over here right now, okay? And if it's directly over the flame, of course, it might damage the camera, so I have to go a little bit off center here. Maybe I'm going to do it like this, so it's a little bit, everything's a little, here are my tools, by the way, my toolbox. It's a little bit off center, it's a little bit tilted, so that it's not directly on the under the lens. So, and I just put everything back into the box here. Just wanted to show this to you, that this is actually something that I'm trying out now. And yeah, in order to melt the slides, I'm just going to start off right away because it might actually take some time. I do the following. Let's put the cap over here. I take a little bit of citric acid, and I'm going to show you now two different methods of how you can do that. Okay, and because both methods will produce slightly different crystals depending on the thickness. Yeah, so I put a little bit of this stuff here, okay, on here. You can see it's a couple of grains here, and a cover glass, of course. But look what I'm doing. I need to make sure that the cover glass. Let me place this on here. Is this one? No, is it one cover glass or is it two? This feels so thick. Ah, it's two. Okay, here we go. So, and I just put everything together a little bit. Okay, and this first method works like this, that you take the dry citric acid and you put the cover glass directly on top of the dry citric acid. And then I'm going to melt it like this, and as it melts, the cover glass will stick to the citric acid and everything will be flat, and then basically that's it, and then I have to wait. Okay, so so the thing is the following. There's a question which is on topic by Paul. Instead of an alcohol burner, could you use the kitchen gas stove? Of course you can do that. I have not used a gas stove for this before, but just used a hot electrical plate and put it on a hot electrical plate. That's of course possible. However, with a gas stove, it's always like this: how are you going to hold it there, right? Because of the heat, you might burn yourself, and for this reason, this is a little easier. So of course it will work. But be careful. There's one thing that I have to warn you. If you overheat it, if you keep it in the fire too long, you're going to burn the crystals and the citric acid, and it's not going to work anymore. Okay? So it's really important not to overheat. Yeah? So look what I'm doing. Here we go. Okay? Yeah, so that's you can adjust the size of the flame by adjusting the size of the wick. You know what? I'm going to maybe, I don't know. See, that's how it looks like. Yeah. Oh, maybe you know what? The camera is now on the side. It's upside down, which is a little bit. Yeah, you don't mind if it's upside down. You understand. You get what I'm doing here. Yeah. I think it's a better view, but I have to do this. Otherwise, the camera is gonna be too. Yeah. See, and it's starting to melt already. It's starting to melt already, and then up, and you have to put it away quickly. Okay? You see, it starts to bubble. You press a little bit, and it will. Let me show here. You see, it's a very thin. It forms a very thin layer, almost impossible. You can see some of the bubbles there, right? They're still there. That's fine. Yeah, and it's still a little bit hot. And then what you do is you just put it to the side and you wait. Okay, and if you're lucky, the crystals will form. Why, if you're lucky? Because because there need to be some so-called crystallization seeds in here. So a little bit of dust and dirt, or maybe some of the citric acid powder that has not melted, will act like a crystallization seeds. And because there are not so many of these basically crystallization seeds are the starting points, right? And generally, I found that here. Especially if the slide is very clean, the cover glass is very clean, what you will have is you will have very few places where crystallization will start, and then you get very nice and large crystals. Yeah, in contrast to the second method that I'm going to show you in just a couple of minutes. Okay, yeah. So this is a little bit the thing here. So I'm just going to, it's still kind of hot. So I'm going to do the following. I'm just going to put it away over here, and I'm just going to make a few of those. Right? Yeah, so I think this also works. Look, I put the camera here on the other side, put this a little bit further away. Let's put this stuff away. Yeah, you see that I have not always cleaned up everything. Let's put this away here. Here are the slides. So let's do it like this. Yeah, I think that's also okay. So let's here I'll take again a little bit of some of the. So You actually don't need a lot. Trial and error is important because yeah, you rarely have exactly the same conditions. Sometimes you take more of it, sometimes less, sometimes you heat it longer, sometimes less. The dust and dirt on the microscope slide might be different as well. This will also change crystallization patterns. Yeah. So let's put this away again here. And I have to reach around the microphone. Yeah, here you're able to see it better. It's starting to become clear, melting. It's still solid. Here we go. Okay, starting to bubble again, as you can see. And then usually I press down a little bit to make sure it's flat, because then you get very nice and thin crystals. But maybe you don't want it to be like that, so I'm going to show you another possibility. Okay, so that's number 2, and I'm going to put it away as well. And I'm going to make a few more of them just because, yeah, for the fun of it. And take a few other. I'm running out of cover glasses already. So, and I deliberately do not clean wipe those cover glasses. They're a little bit dirty, as always, but that's okay. Because crystals seem to be a little bit more interesting if everything's a little bit dirty, because the dust and everything will have an impact and influence on the crystallization process. Some of you might remember, of course, that I bought myself a so-called coffee warmer some time ago. The coffee warmer is there to warm coffee, obviously, but I'm also using this as a slide warming surface. However, the heat generated by the coffee warmer is definitely not enough to actually melt the crystals. Yeah. So this is Therefore, I decided to use a burner. And initially, as I said already before, I used candles, but they basically produced quite a lot of soot. And you can also try to use a gas lighter, like I have over here, to kind of heat it from the bottom. You know what? Just for demonstration purposes, why not? Just put this away over here. Yeah, the gas is already okay. That's also a possibility. Let's see how this works. But then, of course, now you need. I have a hand for holding the slide, and the other one. Okay, now it's melting again. It's continuing to bubble out because the slide is so hot. Sometimes I press down a little bit. Yeah. Has to be a bit careful. Maybe I was overdoing it a little bit. So if it's as soon as it starts to turn a little bit yellowish, you know that it's kind of you've been overdoing this, and then the citric acid burned, and that's or caramelized rather, and that's also something you don't want to do. Yeah. So yeah, I just show you there are different possibilities how you can do that, but I think I'll just stick with the alcohol burner because it's just easier. Let's do another one, just for the fun of it. No, I'm going to now show you the other technique, rather. Okay? Because otherwise I'm running out of slides here. And also because crystallization does take a little bit of time. And what I'm going to do now is the following. I need a little bit more. You can see this. I need a little bit more of this. If I can just get it out here. Okay, I need a little bit more. Let's be a little generous. Okay, I'm going to now take so that's how it looks like. Okay, I now need a second slide. So I'm not going to work with a cover glass, but I need a second slide now. I just put everything together so that it starts to melt more or less on one place, more or less at the same time. And let's go for it again. Okay, have to be a little careful here. Let's put it away from the. Let's shake a little bit. So, yeah. So not everything has to melt, okay? Not everything has to melt. And look what I'm doing now. I'm taking the other slide now, and I'm spreading it over a larger area this way. Okay, and if not everything has molten, then it's fine. And I can actually already see that the crystallization starts here on the side. I don't know if you're able to see this, but there's a white edge forming here. So what I'm going to do now is I'm going to wait until it has cooled off sufficiently. I'm going to now switch off the flame by putting this cap on top. That's it. Then flame is gone, right? And I'm going to put this now directly under the microscope. It's still kind of hot. Yeah. I'm going to put it. Maybe I'm going to put it quickly on the table a little bit for a few seconds to cool it. This one, I'm not going to put anything hot on this surface here. It's a plastic surface. And the reason actually why I put this plastic surface here is not to protect the table, but for the gray background. Yeah, so maybe you can see here already over my dark sweater that there are, it's starting to crystallize already. You see those white areas. So let's put this directly under the microscope. I'm going to put the old slide away. And we're now going to watch this for a couple of minutes, okay? Because we're now able to actually see the crystals forming. And the good thing about citric acid is that this form fairly slowly. And for this reason, you can actually watch them. So where is this? Ooh, look. Look, this actually looks quite nice. So, let's turn up the whole thing. This is the 10 times microscope objective. You just basically pick a place. I don't know, should we just stay here? You go up, no cover glass, of course, yeah? You go up with the magnification here. Okay. And all you do now is you switch on the camera and you basically make a time-lapse video. Okay, so we actually now see that there are crystals here. Normally they should grow slowly, and normally you should be able to see this. I don't know why this one here actually, they're quite slow. If you wait a couple of minutes, you should actually see those two crystals should actually start. Let's have the arrow over here. Yeah, maybe they're going to start touching each other after a couple of minutes, so that you're actually able to see that there is actually crystallization happening. Yeah. I can imagine that a variety of other factors also determining the speed of crystallization. Of course, how warm the slide is, maybe also the moisture present, and so on. Or let's just go up with the magnification yet further, then maybe we're able to see this better. Okay. Let's see if... so this is now 40 times. Yeah. 60 times. Switch this over like this. Yeah, you see that already. Honestly, I've seen crystals of citric acid forming a little bit faster. So the ones before were actually going a little bit faster, but still this one is also going. Yeah. So let's go down a little bit. Let's have a nicer overview. Yep, it's much closer now. Yeah, you can also see that the crystals are a little bit bigger. But let's have a look. I need to do the second. This is too bright. Yeah. So let's just explore a little bit. So usually what I like doing is I go by trial and error, and if I see a nice, some nice crystals, I usually take a picture of those. Yeah, and that's basically what I like doing. So, but okay, here on the other side, it actually goes much further, I see. Yeah. And here we go again. I would say let's just wait here a little bit and let's see how they develop. Okay. And yeah, again, this is the citric acid is crystallizing much more slowly than, for example, vitamin C. Right, when the vitamin C, when the alcohol or the water evaporates, then yeah, you're gonna be very quickly putting them directly under the microscope, because otherwise the crystals are already there. Especially if you use alcohol, which evaporates so quickly. So it's quite different. And here you basically see that it's significantly slower. Yeah. So I'm going to just we're just gonna stay here, and I'm just going to read a little bit some of the questions here. Okay. Again, I'm going to do all of the off-topic questions later. Yeah. The CH20 microscope. I'm going to talk about that. Yeah, I know the CH20 indirectly. Yeah. What do the crystals look like under the microscope before you start the? What do the crystals look like under the microscope before you start the procedure? Thank you for the comment. So basically, what I'm going to do is. Yeah, I'm going to put then later some crystals directly under the microscope. Honestly, I can tell you right away, the crystals before the original crystals, they do not look interesting at all. But I'm going to show you, okay? So, but that's a good point. Instead of an alcohol burner, could you use a kitchen gas stove? Yes, you can. Okay. And I'll go down. So, and yeah, hello from Sydney. From Montreal. So, and I'm just going to skip over. Instead of citric acid, can we just use powder from medicinal capsules to crystallize? The point is the following. If the question is can we just use powder from certain medicine capsules? For example, there are vitamin C tablets, and the question is, can you use those, or can you use tablets of aspirin if you want to crystallize as acetyl salicylic acid? That's salicylic acid. That's actually the aspirin substance. And the problem is that if you use substances that are pressed into tablets or capsules, then they're generally not in a pure form, but they added, the companies added a lot of other filling substances. For example, substances that, for example, are needed to simply have a tablet present. So for example, I've seen some caffeine capsules. As a matter of fact, I have some of them here. And those caffeine capsules do not only contain caffeine, but also contain just indigestible cellulose. And they've added that simply to give it more volume, because the caffeine otherwise would be too small. Yeah, the amount would be too small. So generally, the best results you always get with a pure form. Okay, so if you buy pure citric acid, pure acetyl salicylic acid, pure vitamin C, these substances can be obtained, right? But you might, it shouldn't be a problem to get those, right? But what you can try to do, however, is if you have capsules for crystallization, and try to dissolve it, and try to let the substances that do not dissolve, filling substances, maybe settle down, and then you take something of the liquid, so, and then you try to crystallize that. So, long story. Okay, I see. Okay. Yesterday, the police suspected me of running a drug lab. Centrifuge tube and sciencey stuff is not common. Okay. Make sure to label your stuff properly. Honestly, I have to tell you, sciencey stuff is depends where you are. I mean, there are lots of educational institutions and so on that have a lot of science equipment there, right, for educational purposes. So you see that the crystals are now a little bit bigger, right? And if you want to see how they actually crystallize, you have to go up. Actually, look, this looks even nicer. So, however, not all of you have the polarization optics that I have. So I'm going to also show you then, I'm going to show you how you can actually do this yourself. For those of you who don't know how to do this, it's quite easy to actually do polarized light microscopy. So see, these crystals are now starting to touch each other. This actually shows that they are indeed growing. Sometimes the growth is so slow that you don't even know what's happening. Yeah. But I'm going to show you just in a minute of how this actually is done with a polarized light. But in the meantime, I'm going to show you a video that I also recorded 1 hour ago. It's a 10-minute video. We're not going to watch the whole thing in original speed. So that is the 10-minute video, and nothing seems to be happening. But look what I can do here. I'm able to fast forward. Yeah, and these are citric acid crystals. So I guess you can go reverse again. And the interesting thing is some of the crystals seem to be flowing almost like it's water, right? But I did not add any water. Yeah. But somehow it shows that the molten citric acid still is amorphous and is somewhat liquid. Yeah. So I think it's quite fascinating. Yeah. So this is 10 minutes. Okay. It's just a 10-minute video, and yeah, this is what happens in 10 minutes. Yeah. So quite cool. Yeah. So let's go back a little bit to the scope view, and here we are again. Yep, that's the one. Let's take the arrow away again, and you see that it's quite nice here. Huh? I'm going to read again. Okay. Okay. So yeah, so I'm just reading some comments here. Okay, yeah. So yes, I wanted to show you also very quickly the following. I'm going to now let's go back here again, and I just wanted to show you again a little bit of how you can do this yourself, the polarized work. And what I have over here is, you might already realize what this is. These are from polarizing filters from 3D glasses, paper glasses for 3D viewing, and I simply remove those. What you have is the following. These are so-called circular polarizing filters. Not ideal, but possible. There are different standards, but if you want to use those and if you want to experiment with those, you just have to find an orientation where when you rotate them, that it becomes completely dark. But you have to be careful that because it's so-called circular polarizing, even the orientation here is important, because sometimes if you flip it around, it won't become completely dark. It might appear to be completely dark now for you under the video, but actually it's not. Yeah, you have to flip it around like this, and then it's completely dark. So this means that they are not quite ideal, right? Possible, but not ideal, but I'm still going to show you. However, if you want to make sure that it actually really works, I recommend that you get yourself a sheet of polarizing filter. There's a protective plastic on top. That's why it looks like this, right? What you do is you just basically cut out 2 pieces, and these are linear polarizing filters, and they basically work in both directions. Okay, I'm not using this one. I just bought this for demonstration purposes. But once you've got filters that actually work, what you need to do is you need to place one directly over beneath the slide. Then you put the slide with the crystals on top, and the other one again on top, like this. Yeah, I just can show this to you. Let's use one of them that I made just before. Yeah, so that's over here, for example. You can see that it's completely white already. It's one of the things that I kind of spread. Yeah, I put it over here like this, and I have to lift it up. Yeah, and then if we go like this, then you're going to see that everything is going to be dark. The background, only the crystals, they look white. And what I'm going to do now is I'm going to put this under the microscope, but I'm not going to put it under my compound microscope. I'm going to put it under my stereo microscope. I need to switch it on. Yeah, so because this also works quite nicely, stereo, not quite as clear and crisp and sharp, but this is now. Let me see. That's you can see now the stage. You see this light here now coming from the bottom. So let's do the following. This one here goes directly over the lamp. Okay, see in the top corner what I'm doing, right? Then of course the slide. Like this, and then the second polarizing filter. Okay. And now I don't see anything because it's not focused, I guess. Where did I get the orientation wrong? So where is this? Okay, just a second. Okay, here we go. I was focused. I was to magnify. I have to move this everything over. Here we go. It's a little bit not clear. Okay, and we can now zoom in a little bit more. Okay, I have to focus. Yeah, and that's basically how it looks. Yeah, with this improvised polarization filter. Okay, and I think it's also quite nice. And if you do not want to have the background completely dark, then you just look again in the corner over there. What I'm doing, you just basically rotate one of the filters around, and then you can also adjust the darkness of the background. Yeah. Yeah. Let's see what happens if I flip the filter around. Yeah. Yeah. Then, yeah. You see, then you can even change the color a little bit of the background. The reason is because there is in circular polarization, they have the so-called a lambda plate included, which allows you a little bit similarly to my polarization equipment that I have to also change the background color a little bit, not only making it brighter and darker, but also changing the actual color. Yeah. So in that sense, maybe circular polarizing allows you a little bit more flexibility. And if you flip it around again like this, yeah, and you get it into the crossed setting, then you get the maximum contrast and the background is completely black. Yeah. So this is that's actually one of the reasons why I'm showing you under the stereo microscope, because I have more possibility to manipulate everything. Yeah. So let's see a little bit. Let's go back and let's see how the how do you call this, the other one starting to look like. Here we go. Yeah, you see that everything's already grown together. So let's go down with the magnification. Yeah. So those crystals where I've spread it directly on the slide without cover glass tend to be a little bit, or not a little bit, tend to be often quite much thicker, obviously, because the cover glass does not press them into shape. Yeah. So again, I'm going to have a look at some of the questions here, if there are any questions. Yeah, if you have the maximum magnification and the fastest speed, we can do that. I'm not going to use oil immersion the 100th times, obviously, right? But this is 60 times is the maximum that I have here. I have to turn it up. I have to open the condenser. That's a nice place. Let's see how long it takes the two crystals to actually touch each other. The one from the top and the one from the bottom. Let's focus a bit here. Yeah. You see already the depth of field is becoming an issue here. But let's see. Maybe in a minute or 2 or 3, the two crystals are going to start touching each other. Yeah, and then this actually shows that they are indeed growing. If you put clear plastic with tensions over light source and bright field when having polarizing light, you will also get nice effects. Yes, I have also experimented with that. What is the difference between circular polarizing and regular? The thing is the following, that a circular polarizing filter is a linear polarizing, a regular polarizing filter plus a so-called a lambda plate, which shifts I think the electrical or the magnetic field by a quarter of a wavelength. That's the physics part, and I'll be honest with you, I also do not fully understand it. It can only be understood mathematically, but it actually causes the polarization to rotate. And this, see, now it's touching it. And this basically is used by many, polarized light has essentially, the circular polarized light is used by many camera filters. Yeah, and many sunglasses have linear polarizing filters included, and you also use circular polarizing filters for the 3D effect. Yeah, so essentially there are different forms of polarization, and yeah, we have plenty of things to work with. But linear regular polarizing is essentially the wave. The photon goes in one direction, in one plane, so to say, and the circular polarizing, it's rotating. Yeah, so that's essentially the mathematical model behind it. Yeah. Yes. Could we mix the ratio of water and alcohol to slow down evaporation instead of straight alcohol being so quick and straight water being slower? So this is the question. A water to alcohol ratio. First of all, over here, I'm not using any solvent like water or alcohol. Okay, I've been melting it for those of you who just joined in. However, if you're using, let's say, alcohol water mixtures for making crystals that dissolve, for example, like vitamin C, you have to understand the following, that the alcohol and water evaporate differently. So if you have a mixture of alcohol and water, let's say I'm just in a 1-to-1 ratio, right? And then you try and it dissolves well, then what's going to happen is the alcohol is going to evaporate first until after a couple of minutes, maybe you're going to have a 70% water to 30% alcohol. And then maybe at the very end, maybe 90% water to 10% alcohol, and so on, right? So this means that you're not keeping the ratio constant. Yeah? And this can also then mean it's almost like this, that like if all of the alcohol is gone and only water is left, then it's almost like you only have dissolved it in water, right? So the actual effect might disappear. So but still, what I've done is in the past I mixed in a little bit of alcohol to some substances simply to destroy the surface tension, to make the liquid spread better over the microscope slide. But that's not what we've been doing here, just for clarification, because here I now used actually the heat to melt to make them liquid, right? You see now the crystals have touched each other, showing that yeah, basically still the crystallization process still goes on. Yeah. Can you turn these into permanent slides? That's actually one of the things that I have been also thinking of, and there is a possibility. I've not tried it yet, but first of all, I will show you the following. Yes, we already almost have permanent slides, and I'm going to just let me check here the ones that I made. Just last 1 hour ago. Where is this? Just a second. I have to see where I've got those. Oh yeah. Yes, over here. Yeah, I'm gonna show you. I've made this one over here just before the live stream. I'm gonna show you again. Yeah, exactly the same way like I've made the others, right? But the others are probably not ready yet. So you can see, I don't know, no you can't. Yeah, there is actually a nice crystal in here, and this can already be seen as a permanent slide. Okay, because the cover glass kind of protects the crystals, right? So, however, there is it's probably a bit unstable, because on the side here, moisture is still able to enter the crystals, right? So what I would probably do in this case is after everything's properly crystallized out, I would probably apply on the side here a ring of nail polish. And if you do that, then the nail polish will not only secure the cover glass to the microscope slide, but also will prevent an exchange of air and moisture with the crystal. Right? I think, in my view, the citric acid crystals are pretty stable anyway. But if you were to do something similar with vitamin C, for example, vitamin C likes to oxidize. Yeah, and then it's going to change color and turn brown. But I'm going to, and therefore I would say probably it's more important, but you can make a permanent slide by simply, when the whole process is finished, crystallizing, you just apply a ring of nail polish using a brush, and this will seal off the edges, and this will prevent exchange of moisture. So, but I'm going to show you this here now under the microscope. Again, the black dot here means I made this just before last hour, before just an hour before this live stream, and I'm going to now put this in here just to show it to you, because the crystals that you make, so that's still the old one, right? The one that I just showed you. Now look again at the top here. Yeah, I'm now inserting the second slide, the one that I made before with the cover glass. Let's try to find the place. Where is it? I think. Ah, look at this. Okay. Look at this. Let's do the following. Let's do it here. Here, here, here. I need to. Yeah, and that is essentially a very different, looks very different from the others, other slides, because the crystal is so thin. Okay, and you see over here, right at the center, where it starts to radiate out, that is the crystallization start. Yeah, because the slide with the cover glass also prevents dust and dirt from falling into the citric acid. For this reason, there are not so many crystallization starting points possible, right? And what you can do as well, and I've also done that, I'm going to show this to you as well, is by touching the, where did I put the other slides actually? By touching the surface, you're able to actually also start to initiate a seeding process. Just a second, where did I put those? Here they are, just a second. Here's this one. Yeah. Okay. I have a problem here. Where is it? Okay. I've put it in there. Okay. So I'm going to show you then also how you can do a seeding process by touching the surface. So this here is actually shows, yeah, how, also if we zoom in over here, we should actually also see that the crystallization process continues. Yeah. Yes, this is actually much faster. I wonder, it's actually much faster, I think. Maybe this has to do something with the limited thickness. But look, how it seems to be an air bubble, how long it takes for this edge of the crystal to reach the air bubble. Yeah, or the tip of the arrow. Yeah. So this is yeah, quite nice to observe. I have now I'm reading again here. Yeah, this is an interesting one. The melting point of citric acid is 153 to 159 degrees. Use a digital laser infrared thermometer to see if you're doing it right. That's an interesting point. Yeah. Yeah. The polarizers are made in Hogwarts. Yeah. Is it better to use normal nail polish or UV nail polish? I think it doesn't really matter. I mean, I think UV. Generally, my suggestion is keep it as simple as possible. Yeah. You can also try to use maybe certain glues would work. Generally, I think it doesn't really matter a lot. Which nail polish you use. I think traditionally people have always used regular nail polish that contains, I mean, you gotta be a little bit careful maybe. Maybe that some nail polish which contains acetone or some kind of solvent might start to attack the crystal and start to dissolve it maybe. If it dissolves, yeah, so in that sense maybe UV nail polish might be better. I don't know. Okay, yeah. So that might be something to experiment a little bit. Is what happens if the nail polish actually touches the crystal? Will the solvent actually dissolve the crystal? I guess of course it depends on the substance of the crystal, because yeah, see how it actually goes on now. Yeah. So. Yes, so let's do like this. Let's go down again with the. I have to remove the condenser. Yeah, and in bright field, in case you're wondering, this is how it looks in bright field. Yeah, so you see, you're still able to see the crystals. And why not put this? Why not put this on the stereo microscope now, as well? Where's the stereo? Here it is. So that's the one from before. Let's remove this. Let's take this out here. Put this in here. And this goes on top. Yeah, I have to find the place here again. Where is this? Here we go. Okay. Yeah, and look, if you rotate the whole thing, then you should also be able to see. I mean, it's kind of obvious that this is some kind of a little bit of, yeah. If you rotate this, you can also see that the colors rotate. Yeah, I think that's of course a nice how do you say project to do, maybe to make a special type of stage. I've made this already also, yeah, but to make a special stage where you can actually rotate then the filters, yeah. So maybe that the slide stays, yeah, in one place, and then you're somehow able to rotate the filters. Yeah. So there are lots of things where you can experiment around with, yeah. So can you show the dissolve? Okay, well, you know what? Well, why not? I'm going to now show you the following. I mean, you know, why not try to do the following? You wanted to see the whole thing dissolve. Where is this? Here it is. Let's put this back here. Let's put this back here. Let's put this back here. Let's give it a little bit some more light. Yeah, this here is the one where, yeah. Here we go, here on the side. You know what I'm gonna do? Because this has been a request, can I actually show it to you how it dissolves again? Citric acid does dissolve in water. So I need my pipette, just a second. Some pipette tips, of course, and I need a little bit of water. Where am I gonna use? I'm gonna put some water in here. Okay. In case you're wondering what I'm doing right now. Where is the desk here? I need some water. Ooh, I don't have a lot of. That's an look. My water bottle. Look how yellow and green it looks like on the inside. That's algae that started to grow over the months. It's another interesting microscopy thing to observe. So that's my water bottle that I always use here, but it's not. Yeah, it's not completely free of life, as I would say. So some water here, and I'm going to now do the following. I'm going to take a little bit of water, okay, and I'm going to add it there, and you can observe what happens as the crystals dissolve. I melted them using heat, of course. Now I'm going to dissolve them using water. Okay, let's see how this works. Up. Ooh, also looks nice. Okay. Yeah. So, the destruction of art. Add a little bit of water. And then what we should expect is as the water evaporates, we can of course expect that the recrystallization starts. Yeah. You might actually now notice, and that's an interesting thing, I'm also going to explain this, why does the water not continue to dissolve the crystals, right? It seems to stop. And it's not that the water did not reach the crystals. You can actually see that sometimes the water will actually, yeah, continue to spread a little bit. Yeah, you see over here, it continues to spread. Maybe you're able to see this, but it doesn't dissolve. And the reason is because it's already mostly saturated. Now it goes on a little bit. Yeah, it should actually stop dissolving after some time as the water becomes saturated with citric acid. Then it's not able to dissolve more. Yeah, and so this means the dissolving process is always fastest at the beginning, when the water was not, when citric acid was not so much present in the water, and as the concentration increases, the slower the dissolving process happens. Yeah, so it's kind of, yes, it's saturated. Yeah. And what we can, I don't know, this is going to take probably a long time, but because it depends on the ambient temperature and moisture and so on. And then usually when it starts to dry again, then it will start to recrystallize. Yeah. But because this is such a slow process, I simply tried it today with by heat melting it. And because I wanted to also test out the little alcohol burner as well. Yeah. So I think it's kind of fun doing stuff like this. I mean, that's kind of the hobby. Not very scientifically advanced stuff that I'm doing here, obviously, but it looks nice, and that's actually why I like it. this create, I would say the creative aspect even, because if you do things like this, then you can take pictures and then you can, I don't know, yeah, it looks kind of nice. Yeah. Yes, so this is, I mean, why not try it again? It's just, let's go to a place where there are let's go to a place where there are lots of these crystals here. And let's take again a little bit of water. And let's go for it. And blop. Aha, you see it kind of loses focus because of the water. And here we go. And gone it is. Let's try to find another place here. Okay. Are we already too far away? Yep, here on top we've got the water, but you see the water does not already stopped dissolving. You can actually see it's how it's progressing again a little bit, but so I have something, yeah, so water works quite well. You know what I'm going to try now, just for the fun of it a little bit. Something I never tried is let's see how well it actually works with alcohol, right? I've got also a little bit of alcohol here. Let's put some of this, yeah, the same alcohol for the burner. Alcohol bottle here. And let's see if the citric acid also dissolves in alcohol. Okay. Now you have to be careful with those alcohol fumes. You got to be careful. If there's a fire, of course, then yeah, it can burn quite quickly. So let's take some of the alcohol here. And again, scope view. Let's remove the arrow again. Let's see how this looks like. Up. Oh, look. Look, do you see those? It also works. Let's see if because of yeah, that's nice. Didn't expect alcohol also to dissolve the citric acid. You can actually see those, the differences of refractive index. You see those almost cloud-like structures, and maybe because the alcohol evaporates faster. Let's see if recrystallization also happens faster. Look how the alcohol carries away those crystals here, but it kind of stopped dissolving them already. The thing is there is of course a little bit of water present as well from before. But let's be patient now. Let's see if recrystallization is going to happen here as the alcohol, and the alcohol has a much lower surface tension, so it spreads much faster, right? This image is magnificent. How big can you print with your actual resolution? Well, I've got a so-called a 4K camera attached to it. It's an Olympus D90. It's not full format, and I'm basically right now the video that you're seeing right now is not 4K. It's just regular full HD, because when you're transmitting the stuff over the internet, of course, you do not need that resolution, and it would slow down everything much more. But generally, I would say that it doesn't. Pretty much all cameras these days give you way more resolution than what the microscope is able to deliver, right? And sometimes it is like this, that the limit of resolution is sometimes not even the microscope as well, but sometimes the specimen simply does not provide enough details or contrast, and therefore actually it doesn't really matter how good your equipment is if the specimen is simply not sufficiently detailed, let's put it this way, right? And then it also doesn't look quite nice. So I've often found that that there are other factors that play a role, right? You see, the whole thing seems to have not dried out. No, not yet. There are tiny crystals here. Let's see though if those tiny crystals that are floating in the background, if they actually start to grow again. Or over here. Here, tiny ones. Still liquid because some of them are moving. Go up a little bit with the magnification here. maybe they're going to start growing. I don't know. Yeah. The thing is the following, that because there I had already a drop or 2 drops of water on here, it could be that the alcohol kind of mixed now with the water, and therefore there might be now not only alcohol present but also some water which evaporates much more slowly. Yeah. So actually, strictly speaking, what we have to try to do is we have to try to take a fresh slide, maybe this one over here, and just put alcohol on top of it. But look, the crystals do become bigger. Yeah. Do you need 100% alcohol for the burner? No, 100% definitely not. This is, I don't know, is it a 96% or something? Okay. As a matter of fact, you won't get 100% alcohol. Because that's as soon as you open the alcohol, and if it's in contact with air, it will immediately start to absorb moisture. I think I have not tried 70%. I think it's 90 something percent. Let me check. Let me check. So let me see. This says here. What does it say? I mean, it's a refilled one that I have. I think it must be 90 something percent. Let me see. I don't know. It doesn't say. It doesn't say. Yeah. Usually it's something over 90%, but never 100%. Yeah. 100% alcohol is expensive to get because it has to be completely free of moisture as well, and you have to store it carefully as well. Yeah. Are these tiny rods the basic crystal structure of citric acid? Well, I don't know if they're the basic ones or not. I mean, I've seen that there's so many. I know that there are certain. Thank you. I know that there are certain crystals that essentially have a preferred shape, but I can imagine that, depending on the circumstances, for example, the ones that we had before beneath the cover glass, it started to spread out the circular form. So I've seen that essentially, depending on the circumstances and the conditions, you have different ones forming. Yeah. So, can I increase the magnification? Of course. Let's go up. This is now 20 times, 40 times, and let's go here just a second. I have to switch the condenser here as well. 60 times is the max that we can go here. It's and of course then the how do you say, the depth of field also goes down. Yeah, I don't know. Are they growing? Yeah, let's just keep it like this. So that's the maximum that I can go right now. But again, you know what? Let's just try it again. I'm going to now just add alcohol. So I'm going to take a fresh slide. Okay. Now this mixed with water. I can show you. Look, I can actually show you. So this over here, you see that there is still some water left. The alcohol that I put over here is gone. So yeah, the alcohol spread, mixed with the water, evaporated then, and so this is therefore not going to crystallize very quickly. So I'm going to take a new fresh slide over here, and I'm only going to add alcohol. And where is it? Too much. Yeah, this is very dense. Okay, so this is extremely dense. Extremely dense. Let's go up here 20 times. I gotta be careful that not too. So yeah, so that's basically. Let's have a look here. I'm going to now take again some alcohol and let's give it now a try. I can apply it a little bit to the edge here because it will spread quite easily over the whole slide anyway because of the lack of surface tension. Look at this. It's almost like ice or continents breaking off, or I don't know. Yeah, and see, it seemed to have stopped again. Oh, a donation. Thank you very much. I thank you very much for the financial support. The money that is donated, I save together, and I always use for microscopy related things. And I can tell you that much. I have ordered 10 slides, not antique slides this time, but slides which are medically relevant. So slides with blood containing malaria and some other diseases. So I also out of personal interest. They have not arrived yet, but these are slides used for medical training purposes, and I'm going to, of course, share them with you once they're here. And I have to tell you, it's going to be a little bit new for me as well. So I have to do a little bit of research as well. It's a learning process for me as well to understand and the cross sections of the tissues. What do they actually show, right? But I just wanted to tell you that this is how I'm going to use your support. So a big thank you. Okay. So this is basically. You see, it's starting to dry now. You can actually see here that how the alcohol starts to retract again. And then maybe the crystals will grow again. Well, let's give it a try. Or maybe a different place here. See here it's still liquid. Yeah. What I'm going to do is I'm just going to leave it here like this, okay? And I'm going to go through some of your questions, okay? So this is wow, some very nice comments here. Okay, thank you. So I'm going to do the following. Off topic, can you identify some bacteria using an electron microscope? Obviously, DNA analysis is probably more accurate. This is the question. Can you identify, if we put bacteria under a microscope, electron microscope or light microscope, are we able to identify bacteria? And this is not a yes or no question. It is more a question. Well, the answer is generally no, but it depends also maybe a little bit on what detail do you want to have the bacteria identified. Let me summarize it as such. Microscopy is not enough for you to identify bacteria. That's the bottom line. However, there are some bacteria that have certain characteristics that essentially are typical for only few bacteria. For example, if you see bacteria that form so-called endospores, these are basically capsules that allow the bacteria to survive at dryness and heat. And those endospores are only formed by a few types of bacteria. So if you see those endospores, then you already know that what they could be, right? Or if you see long spiral-shaped bacteria, then spirochetes, or spirilla, then you know that these are there are also certain types of bacteria. But still, the biodiversity is so large that generally, for all practical purposes, you want to identify them all the way down to the species level. Generally, microscopy is not enough. So it is really a question. I mean, the analogy that I'm giving also to some of my students often who ask similar questions is it depends a little bit. Well, if a vehicle has wheels, right? Then you know it's a vehicle for transport, but you don't know if it's a bicycle or if it's a car, right? But maybe you're just happy knowing that if it has wheels that it's a vehicle. If that is all that you want to know, then knowing that it has wheels is enough, right? But if you actually want to know that whether it's a bicycle or a car, then you need to know the number of wheels. So you see what I mean? It depends very much on the level of detail that you want to go. And in some cases, you have to do a detailed chemical analysis or DNA studies to actually be sure that actually what bacterium that you've got is actually something new, right? So that is the thing. So microscopes have their merit, especially for characterization, but not enough for actually saying which type of bacteria it is. Is the CH20, that's the Olympus CH20, a good microscope? This is a philosophical question because what do you mean with good? Okay, different people have different expectations. Generally, CH20 microscope is, if I remember correctly, the CH2 or CH20 is a follow-up of the CHA and series of Olympus. Those microscopes, these are brand microscopes, generally are good if they're in a good condition, and they are serviceable. And that's one of the good things about those traditional microscopes, even if they're not made anymore. Sometimes there is quite extensive documentation available. For example, I got myself a couple of years ago an old, from the 1970s, an old Olympus CHA microscope. Yeah, which was not usable anymore because the lubrication oil was so hard that I could not even turn the focus knobs anymore. And I basically did the following: I took the microscope, I gave it to an Olympus service company. He serviced the microscope. It came back almost as new, and it's usable. Right? This is something that generally is not possible with modern microscopes, right? So I would say if it's a good microscope or not is really a question of what your own expectations are and on the actual condition of the microscope. What do the crystals look like under the microscope before you start the procedure? That's something I promised to do and which I didn't do. I'm going to do this now very quickly. Okay. Thank you for reminding me again. Those crystals under the microscope with, you see now it's starting to crystallize here. Desk view. Let's put them directly here. Yeah, and lower your expectations. Lower your expectations because they're fairly thick. And because they're so thick, they generally don't look very nice. Okay, so let's have a look here. Scope view again. So let's carefully put on, because there's no cover glass or anything on it, right? So let's have a look. This is how the crystals look like, yeah, directly original. Very irregular. They might have, maybe they did have a irregular shape before, but because of the transport and because they're rubbing against each other, yeah, they lost quite a bit of the of the original beauty. Yeah, so here we go. Let's remove this here again. So no colors, no polarization or anything right now. Yeah. So that's basically how it looks like. That's why, yeah, you gotta, if you want to have something nice, you have to dissolve them or you have to heat them up, just like we've done here, right? In some cases, you can actually might be even able to guess that, yeah, that it was actually quite crystalline before with sharp edges, but now, nah, yeah. So not so cool. You know what? Who cares? Let's dissolve them as well. Yeah, we've seen that alcohol works, so I'm gonna use again alcohol, simply because then it works faster maybe. Here we go. Look at this. It looks like this movement here. That's because of a change of refractive index. It looks pretty cool, actually. Yeah. And it looks very dark because the light is being refracted around it. So everything looks like having a dark ring around it, right? So the actual crystals we're not able to see anymore. This is actually I've not tried this before. This looks really cool. The how do you say all of those, yeah, things here. And then if we wait, then let's do the following. Then let's just wait, and as the alcohol evaporates, maybe it's going to recrystallize again. Yeah. So let's keep it like this. I go down the questions here. Okay. So I answered some of them already. Can you turn them into the permanent slides? Then no, I answered actually most of them. You should use this in a YouTube short and slow music. Thank you for the recommendation. I probably am going to do that. You probably can use the image stitching like astronomy to make very large print if needed. Yes, image stitching is something I've also done already before. This is basically when you are taking several overlapping images and then connecting them together into one final image. The program that I use to do that still is available somewhere. It's called MSICE, Microsoft Image Composite Editor, and allows you to connect images together, which normally panorama software assumes that your camera is mounted in a central point, and then you're rotating the camera, right? And the software will try to then make a panorama. But in the case of a microscope, we do not have a rotating camera, but actually a planar movement. And this MSICE program, Microsoft MS, then hyphen ice, like ice cream. This image composite editor allows you to actually combine those images together also in a planar motion, and for this reason I really recommend this. It can be downloaded for free. I think it's not maintained anymore, the software, but there are still places where you can download it. Yeah, so like a Schlieren image, yes, yeah, that's, yeah. So and now what? Let me see. I mean, of course I can add colors like this here. Yeah, this again the polarization, because I've got this DIC thing, but it's still, yeah. I wonder if it's starting to recrystallize now, because it could be that the alcohol, even if it's gone now, there's an amorphous. You know what I'm gonna do? I'm gonna show you something else, just to show you how you can what you can do to restart crystallization in certain places. What you do is you take a crystal, look with a tweezer, yeah, and you start to break it apart or move it around, and tiny crystals will break off, and this will be then a starting point for new crystals forming. Yeah, or maybe we already have something here happening here on the side. See? It's a little too dark still. Yes, here we go again. See? Actually, I just realized this is actually much easier than heating it up using the burner. Yeah. Honestly, I never tried. Honestly, I never tried a citric acid with alcohol, and this is actually much easier. This is okay. Yeah. So, would oil destroy the process? I don't know about this. The thing is the following, because oil, because this is very hydrophilic, so this means water soluble, and so I don't know if oil would even interfere so much in the process at all, if the crystals even recognize the presence of oil, yeah, because they don't mix, yeah. So I don't know. Again, there's always new stuff to discover. The funny thing is this seems to work even faster than yeah. So let me quickly have a look here. Yeah, so let's maybe, what time is it? Yeah, still a couple of minutes, but let's have a look at some of the slides that I made right at the beginning of this live stream. Yeah, because I see now that there is also a little bit of crystallization happening here. As a matter of fact, yeah, quite a bit. So let's, on two of the slides, on the third one not. Okay, so just to complete everything, I'm going to put the slides under the microscope, which we made at the beginning. Yeah. Yeah, this is thank you, very nice for comment. This is a very beautiful live, very impressive images. Even the technique is very basic. Even if the technique is very basic, we have a great fun with you. Thank you very much. I tell you, this live stream was a little bit of a before I started the live stream, a little bit of a stress, because this was a last second decision that I actually am going to do that. Maybe if you joined in the live stream or looked at the thumbnail a couple of hours ago, it was still a very generic thumbnail, and only shortly before I started the live stream, I decided I'm going to try out the vitamins, the citric acid crystallization. Look, this is really how do you say, spreading quickly. You know what? Again, I know this looks nice because of the colors, but again, most of you probably are just going to use regular filters, regular, how do you say, polarization filters. So I'm going to show you how this looks like under regular polarized light as well. So, you see that's overexposed. Also nice. Okay. Yeah. So also it's a little bit fuzzy what it looks here because it's my stereo microscope. So of course the resolution is not quite as high. Yeah, but it's also oh, this is almost Christmas like I don't know, ice crystals or something. Yeah. So also quite nice, huh? Yeah, so that's basically it. We just leave it like this here. If you want to do this with polarized light, generally what I recommend is that you indeed, for the best clarity, put one filter directly beneath the slide and the other one beneath the objective and the slide. Because you're going to be using low power in most cases anyway, there is going to be enough of a distance. Yeah? If you try, the more optical elements you have in between, the more the light becomes depolarized. You can also try, I've also done this, also works, to put one of the filters directly on the lamp. It's also possible. Yeah. Yeah, this one is also going pretty quickly. Again, what fascinates me so much here is that so much depends, the crystallization is influenced so much by the different conditions. The solvent that you use, whether it's between a cover glass or not, yeah, and it always look different. Yeah, so there is lots of trial and error and experimentation and everything that you can do here. Let's go really out here. Yeah, you see over here, for example, that's also something I want to show you. Where is the arrow? And here's the arrow again. You see those white, these are the original, yeah, crystals. Yeah. Which basically were left over, they have not fully dissolved yet. Yeah? And then the alcohol, I added the alcohol, it kind of dissolved them partially, and then now everywhere where the alcohol was, it started to recrystallize. Yeah? Yeah. So, I'm going to, there's still a couple of comments here. Let me quickly go through those. Yeah, very beautiful. Yes, even if the things you try fail to have success, it gives me ideas on what to try. So it's never wasted time and you don't need to stress about it. Yes, as a matter of fact, this is actually a little bit the philosophy of this channel and the live stream is it does have a slightly improvised nature deliberately because actually, I mean, I've got a lab background as well. In the previous video, I mentioned that I've got a microbiology background. Most experiments during the lab, they didn't work because really the majority didn't work because we always have to keep on optimizing and changing and then you've overlooked something and it didn't work. So actually success was actually sometimes in the minority of happening in the minority of cases. And if you always only show the successful things and not the improvised things, then people, especially beginners, might get the impression it's going to work all the time. As a matter of fact, in the videos that I show, I only show the nicest pictures, right? And only the things that work, right? And for this reason, the live stream gives you a little bit of maybe a more natural, how do you say, impression, right? And this basically means that sometimes I also don't know really what to expect. Yeah, and that's why I also consider the feedback from the community so important because I'm getting some suggestions that I have not even thought about, right? So, for example, I didn't think about okay, how do the dissolving them again, right? I was actually planning out the whole thing just using the gas burner and showing you that, right? Yeah. Why should we use low magnification? Low magnification, first of all, has the advantage for a couple of reasons. First of all, the crystals are fairly large anyway. number one. Number two, if you use low magnification, you have a larger distance between the slide and the objective. So it's easier for you also to add substances to it, right? So for example, right now the magnification is actually really low. It's the lowest magnification that I'm getting now with my stereo microscope, right? And you're still able to see patterns. Yeah. So, and it's simply for practical purposes. Yeah, and that's the good thing about crystals, because they're generally very large and you give you large patterns. You can use low magnifications. Yeah. Can you use a hair dryer or ice cubes to play with speed? Sure. I think why not? I know that that temperature does play a role, right? But there are so many variables that have an influence here, like moisture and everything. That the strongest concentration of alcohol you can achieve by distillation is approximately 96% pure. Okay, you can get higher percentages as well, but it's much more expensive, because they have to do an additional dehydration step of the alcohol, right? And for this reason, higher than 96% is quite expensive. Yeah. Can you ever try fixing small wire on microscope slides submerged with flux with some solder? I did that several times, and I'm sure I observed electromagnetic fields, particles of tin flowing in spirals. Oh, interesting. Okay, because the tin particles will follow magnetic fields, and for this reason, okay, that's interesting. Okay, I can maybe even imagine maybe some iron powder, something that maybe that would also be possible, maybe that they also follow. Yeah. Somebody once said, when I don't know what I'm doing basic research. There is a saying, what time is it? Okay, yeah. There's actually a saying that, I don't know who said that, but the big discoveries in the sciences are not made with the words, oh, I discovered it, eureka, I discovered it. Yeah? This is not how the important discoveries are made. The important discoveries in the sciences are made with, that's funny, that's strange, I didn't expect that. Why is the result so strange, right? And usually then, that this could be an indication that you're up to something new, right? So that if you say, I didn't quite expect those results, right? What's going on here, right? So that means that might be something, to explore here. Somebody, I don't know who it was, a scientist once told me we're getting stuck because all of the experiments work out the way that they work out. Yeah, and we're always getting the expected results, and that's a bad thing, because then you don't really know if you're up to something new, because if everything turns out the way that you expect them to be, then you're just basically confirming that what you already know, right? But if you want to make new discoveries, you hope for results that are kind of a little bit strange, right? Yeah, I'm digressing. Yeah. Do you have a follow-up for 2025 to get a few YouTubers to join a live event? Basically, yes. I don't mind. We've a couple of weeks ago I tried Jitsi, which is an online video conferencing platform, which worked quite easily and quite uncomplicated. There was a link, you joined up to that link, and then it was quite easy for me to integrate that. So I would say, if you, my suggestion is that's something maybe for the new year. If you want to present something, and if you're able to kind of set it up with a video conferencing system, even with a mobile phone, it works, right? Over Jitsi, then please drop me an email, and I'll try to join you in, right? And it's really technically, it works, right? And I would say also, please keep it simple on your side. You don't need to have this fancy OBS setup that I have. If you have a mobile phone with a reasonably stable internet connection, you can basically join in. Yeah? So I just need to know in advance. Yeah. So let me quickly say, and then I'm slowly going to call it a day again. So let's see. The current slides looks like flower, like flowers. Yeah. and that during experiments they always want to get a different result from what they expect. Yes, yeah. While I'm thinking how this, yeah, metabolize in the body. Honestly, citric acid is a very central substance in cell respiration. I don't want to go into the details of biochemistry, but citric acid is actually, it's the so-called the Krebs citric acid cycle is a fundamental process in how substances are metabolized in the body. So actually, yeah, that's biochemistry now. But citric acid is indeed, yeah, part of, occurs in the mitochondria of our body because it's a central substance in the breakdown of organic substances to release energy. Yeah, so. Yeah, I don't have proper camera setup, but I know some people here do. Well, the thing is the following: you don't need a fancy camera if you're somehow able to connect maybe your mobile phone over the eyepiece. Then that would already, yeah, in a sufficiently stable way. Then I think that would be fine as well. Yeah. Yeah. So I'm quickly going through the last comments, but otherwise, yeah, I had to learn that cycle in high school. Yes. Yeah. So, but I like this live. The crowd has so many people with different expertise and personal experience. Yes. So this is kind of, I think that the crystallization process now stopped. We can have a quick look. Yeah. Again, maybe as a last thing, because what I'm going to do now is the following. We're going to have a look at the slides that I prepared, or that we prepared, we might say, right at the beginning. Remember those that were put the cover glass on top. Let's see if some crystallization has already happened. Well, here we go. Yes, it did. Yeah. So that's basically the result of look at this here. They look like feathers. Yeah. So it looks like feathers here, right? So that's again, these are the ones that I made right at the beginning. Yeah, and you see over this last hour and a half maybe. Yeah, this is basically what we got here. Yeah. And maybe I see that there's another one as well, but the third one didn't, because apparently maybe the slide was too clean, so there were no crystallization starting points. So that's the other one here, where I've got a lot of irregular crystals here. You know what, let's go down with the magnification again. So simply to get a better overview. That's now the 4 times objective. Yeah, it looks a little messier here. Lots of, yeah, this seems to be unmolten crystals over here. Yeah, several crystals started over there. Oh, there's also kind of a nicer flowery, nice and flowery appearance. There's an interesting ring around it. Okay, and the last one over here, I think, I don't know, we're not even going to try, I guess, or maybe the crystals are so small still that I don't see them. But this one over here does not seem to have a lot of crystals. Let's have a look. Let's go again down with the magnification to the... See, that's this line that you see here, that's the edge of the cover glass. Okay. Are these crystals here? It looks like a little bit like, look, this is a fiber. So maybe some dust or dirt or I don't know. No, but there seems to, maybe there's some, there, interesting. These are definitely crystals that have formed in here somewhere. It could be that maybe indeed there was some kind of a, I don't know, dust fiber here or something. Or something which caused it to start the crystallization process. I don't know. Some air bubbles. Yeah, but I think you get the idea that trial and error is important, because not every slide will actually form crystals. And the one over here, the other one from before, plenty of them. Yeah. So. Wow, it's already over 1.5 hours. I kind of really like this one. I did not expect myself that it's actually going to work out that well. So last comments here. Yeah, you entertain a lot of people with about 1 penny worth of white powder. Yeah, that's correct. Sometimes you don't need expensive stuff. That's the thing, and that's why I recommend always, because many people think, or some people think from the emails that I get, you need expensive equipment. I mean, I admit I've got a nice microscope setup, no question. But you look at this here. I mean, this is low cost, right? So it's really low cost, homemade. Yeah, filter setups also work extremely well. Yeah, and I think that's also part of the hobby, to try to achieve nice results with very little, yeah, with very little financial input here. So time flies. Yes, that's correct. I'm going to leave it at that. I'm going to leave it at that. I'm going to, I know, as always, I'm going to struggle again next week finding interesting topics. So I'm always appreciating suggestions. And of course, yeah, as already mentioned, if you want to also join into the live stream by sharing some of your projects, please, yeah, drop me a line, email or so, and then we can I can try to include you. I might not work technically all the time, but that's fine. Right? It's a little bit improvised, everything. So if it doesn't work technically, we'll try to figure it out. And if it's not perfect with the camera setup, as long as we're able to see something, I think, as long as we are able to have a little bit of interesting fun together, I think it'll be fine. So we do not, things don't have to be perfect all the time. That's just what I want to say. Okay, people, I wish you all the best. I do plan to next week is the 21st. It's just right before Christmas, but I'll try to be online again. If for whatever reason it doesn't work out, I'll post something. Okay, but now I'm just gonna say bye bye. Is the best place to leave a suggestion? Oh, another donation. Thank you. Is there a best place to leave you a suggestion on the old video? Yes, you can leave comments, because I'm reading the comments. And on those live streams, I generally don't receive a lot of comments anyway, so it's easy for me to see them. Right? Thank you again so much for your financial support. I wish you all the best. Happy microbe hunting as always, and see you again in an upcoming live stream. Bye bye.